Salut and welcome to this AMSEL video. Today we are talking about autoreactive T-cells that lead to MS, and joining us is Professor Roland Liblau, this year's Sobek Prize awardee. Bonjour à Toulouse, Professor Liblau, and congratulations to the Sobek Prize 2025.
Hello, Dr. Fleischmann. Thank you very much. It's really a great honor to receive this Sobek Prize this year, which has been awarded by a committee of highly respected peers.
You have earned it. You do work as a physician and scientist. Could you please briefly introduce yourself?
I am a neurologist, but my work primarily is into research, teaching, and training of young scientists. I'm heading an academic laboratory in Toulouse, which is devoted to the study of the mechanism underlying and responsible for inflammatory diseases of the central nervous system, in particular multiple sclerosis.
Today we want to focus on just one part of your work, and that's the CD8 plus T lymphocytes. What kind of cells are they? What role do they play in MS? And how could your findings help people with MS?
So T cells are immune cells that recognize specific antigens such as viruses. CD8 T cells is just a subset of T cells that is characterized when they are activated to kill other cells that contain their antigen. For example, virally infected cells. However, in multiple sclerosis, like in other autoimmune diseases, the CD8 T cells are misguided. They not only recognize and attack foreign antigens, but they also attack cells that express normal proteins in the body. And our work has shown that autoreactive T cells can, in experimental models, induce demyelination, the loss of myelin. They can injure axons and neurons, and they can even destroy the blood-brain barrier. And therefore, preventing the activation of autoreactive T cells, preventing their migration to the brain and spinal cord, or preventing their persistence in these tissues has great therapeutic potential for multiple sclerosis.
Thank you very much for this insight. What are you working on currently?
So currently, our work mainly addresses whether autoreactive T cells that persist in the brain and spinal cord contribute to the chronicity of local inflammatory processes. And we have recently accumulated evidence that it is indeed the case, and therefore our future work aims at interfering with the long-term persistence of autoreactive T cells in the brain and spinal cord, with the hope to curtail the progressive phase of multiple sclerosis.
You're very well known for your collaboration with other scientists, and that leads me to my last question. Why is teamwork so important? Why is sharing so important?
So science is obviously best performed through collaborations. Putting together complementary expertise allows us to achieve more. And I was fortunate over the years to be involved in 8 different consortia sponsored by the European Union, and allowing us to develop extensive collaborations with other European colleagues. Collaboration is also with a patient organization, and I have worked for almost 20 years with the French Multiple Sclerosis Association, called now France CEP.
Thank you very much for this lovely closing, Mark, and thank you for our conversation, Professor Liblau.
Thank you. It was my pleasure.